Yes, good morning all of you. Today we have to study about the universal testing machine. In our laboratory, the universal testing machine is there having capacity 400 kilonewton. Okay, basically it is composed of two different units. One is called as control unit and another is called as hydraulic unit. This hydraulic unit which is composed of three different crosshead which is called as top crosshead, then this is middle crosshead and this is bottom crosshead. Using this, the hydraulic unit, we have to perform here different tests such as bending test and compression test. Here also we have to perform shear test also. Now see here, if you have to perform the tension test between this crosshead, that is our movable crosshead, which is moved by using the control panel button is there up and down, isn't it? There are basically two different valve is also there. One is called as hydraulic valve and this is our loading control valve. Means by using this valve we have to control our load, because the once we have to consider our the tension test, we have to require the gradually applied load. So by using this valve we have to control our loading rate. Similarly, another valve is there, that is our hydraulic valve. By using this hydraulic valve, at the time of performance it is just close. Because of that close, see here there are the this is the connections between the control panel and hydraulic unit. So because of that, in this control pipe we have to require the some hydraulic pressure here there. Because of that hydraulic pressure, naturally load is occurs and we have to apply that load on that particular our beam element and our rod also for tension test. Now during at the time of performance, always remember this valve which is closed, and after that performance we have to open it. That's why we release that hydraulic pressure. Similarly, if you see here, there are four number of buttons is there, up and down. If you have to see here, if it is up, so naturally they said it is movable. It is movable. See here, if it is down, so naturally it goes on downward side. This is our the column, that's why it is called as loading frame also. Now see here, this is the another grip is there. Once we have to perform our tension test, that grip it will be changed according to diameter of our rod. Whether it is 8 mm, 10 mm, 12 mm and 14 mm, it can be changed. Now see here, in during the bending test, two six supports are there, which is called as our fixed support, which is called as our simple support. Now that's why we have to perform here bending test. Now see here, different holes are pitch are there, pitch distance are there. According to that, it can be changed the length of our beam also. For example, if you have to perform our test on the length of beam is 100 centimeter, 80 centimeter, 60 centimeters. So according to that, the position of support it will be also changed, isn't it? So here we have to perform our bending test and here we have to perform our tension test. Clear? Now this is our control panel. If you have to see here, this is our loading, how much amount of load which is act here. So see here, this is the normally this is 10 kilonewton point volt. So naturally, before performing our test, we have to first of all tear it. Tear it means which is considered as a zero. Now see this machine which is our totally computerized based machine. So this computer which is connected here. If you see here, the computer, the whatever loading is there. See here, this is 10 kilonewton, isn't it? And the displacement is 0.5. Now how it can be operate here? Now see here, I want to tear it first. So I see here the tear displacement, one option is there and tear load is there. So naturally it gets 0, 0. Now see here the test type is there. In that test type we have to different test we have to conduct here, that is called as tension test, compression test, bending test, spring, single shear or double shear. For example, I consider to perform the tensile test. So automatically if you see here, there are two different types of graph which is shown here, load versus displacement and stress versus strain. If I consider, if I click on tension test, only that condition we have to uh, click on stress versus strain graph, otherwise we cannot click. Now see here, if I click on compression, it cannot be click. So only in compression bending we have to get the another graph that is called as load versus displacement graph. Only in tension we have to get stress versus strain graph. Isn't it? Isn't it? Okay. Now see here, there are different type of specimen which is available, whether it is round, whether it is hollow, whether it is flat, whether it is torque steel, whether it is bone. According to that, we have to perform our tension test, whether it is our bar is simple round, that is mild steel is there. If it is torque steel, that is threaded portion is there. That flat which is applicable for bending test also. Here, now here, if I perform the tension test and torque steel is there. So I write here, okay. Now see input data is there. So that batch number which is showing your batch is for example A1 batch, and you have to write there reference A1 batch. Here the serial number you have to put your the today's date, that is 18.8 2000. Here. Now the initial diameter we have to require here, initial or final diameter. Now we have to perform here tension test. That's why our diameter it cannot be changed, but gauge length it will be changed. Now here I consider the 8 mm diameter of bar. The length of our gauge length, that is important. So see here, as per our see here, this is our rod. Are you see there? The total length of that bar is 600 mm. Okay, I mark here the center of that bar, and according to that, what is our gauge length? Gauge length, always remember the 5 times of diameter. 5 times of diameter if it is 8 mm bar. So what about your gauge length? 5 times multiplied by 8, that is 40 mm. If I mark here center, and from this center I measure 2 centimeter from this side and 2 centimeter from this side. Similarly, from that point you have to measure 4 centimeter, 4 centimeter and 4 centimeter. Similarly, here also I measure 4 centimeter, 4 centimeter, 4 centimeter. Why it is required? Because I want calculate here percentage of elongation. After applying the tensile load, what I want calculate the percentage of elongation, delta L value. How it will be get? It is depends on, because we don't know whether that bar which is break here, here, here. After that, performing that particular test, we have to again the bar which is joined, and we have to check whether that length it will be increase or not. So it is totally depends on our gauge length criteria. If we fix that bar, so that's why the measurement of that bar we have to measure. For example, if it is the 600 mm, you have to measure the center. So at least 12.5 distance which is required for grip. Okay, required for grip. Why it is required for grip? Because if I apply the tensile load, it cannot be slip. So that's why at least 12.5 centimeter length which is required for grip, and then you have to apply. Now see, in most of the cases we have to apply directly here also, or some of the experiment, or some of the if you have to see the YouTube videos, they have to perform some gauge length. If you have to, they have to consider the 20 mm diameter, then it is shrink according to that, and then you have to consider for 8 mm, or you have to apply this throughout the diameter of bar is 8 mm. It totally depends, but we have to consider here total 8 mm bar. According to that, we have to measure the gauge length, isn't it? Now see here, we don't know what is our final gauge length, but we know the original gauge length. So original gauge length is 5 times of 8, that is 40 mm. Here, this final gauge length you have to put here after performance of your test. What is your weight? Weight is, it is in gram. 215. So 215 gram. Okay. Specimen length is 60 centimeter. That is 600 mm. So it is directly given. If you see the weight per meter, it is automatically calculated. If I put the diameter, it can be automatically calculate the area. effective. Now here the two parameters is there which is called as preload and delta. Okay, that preload which is totally depends on our loading rate. Now if you have to see here the loading rate, if you have to see here the loading rate is, it is kilonewton per meter. Now we can change that load also, but as per our the fixation for tension test we have to fix here 0.8 kilonewton per meter. Now we have to see here the loading capacity, we have to consider 0.1, so that increasing of that load, for example it is 0.04 kg. If I apply that load, so it is increased by 0.4. Means after that it is considered as 80. It is considered as 44, 48, like that. And we have to check it whether it is correct or not, isn't it? So this is all about our input data. Okay. Now we have to perform here by using that particular graph. So we have to require some parameters, xy parameters. What is our minimum parameters and maximum parameters? So minimum parameter is 0. Maximum we don't know whether it is elongated 50 mm, 60 mm. So this is our random value we have to put. Okay, any one value you have to put, but that test which is top according to that whatever load it can resist. Okay, so I put here 50 kilonewton, but I don't know whether it is 50 kilonewton or 100 kilonewton, but you know that the capacity of UTM is 400 kilonewton, so just I put here 100 kilonewton for universal testing machine. Now this is our output parameter, whatever the output parameters which is required here, whether it is ultimate load we have to require, ultimate tensile strength is also required, displacement is also required, maximum percentage of elongation is also required. So whatever parameters you have to require, you have to just click it, isn't it? So the unit is also fixed here, kilonewton per mm square. Okay. So I put here okay. Whatever input parameter is there, you have to check here whether it is right or wrong. If any one parameter is wrong, so you have to again back to our test and change it. Clear? So now here instead of going through that S, now our specimen is not fixed in that particular hydraulic unit. So I consider here no. If our machine is set for the experiment, then I start it yes. Okay. So I just put here no. So see here, wedge here, and you have to see here. Is it clear? It's good. Now they have fixed our rod, and then we have to start our test. You have to see here how it can be set our rod. Okay, that wall is there which is required for fix that rod. Similarly for that movable crosshead is also there. You have to move it by using that particular key up and down. See here. The fixation of that rod, that is also important, how it can be fixed. That is basically very, very important. That precaution you have to take. You have to consider which type of precaution you have to consider during the test. That is important. There are so many videos available YouTube. You have to refer that video also. But this is our laboratory machines. That's why we have to record that universe tension test for your reference. We have already studied about this stress strain curve. So whether we have to apply for stress strain curve, now one extensometer which is required for that particular value. That's why we have to get that proof stress. Okay. So instead of going through that stress strain curve, we have to consider here load versus displacement. Both are same thing. Before the performance of test, we have to check it whether it is perfectly fixed or not. So now again I start my test. So before to start, so always remember the hydraulic valve is again closed and the loading valve is open. Clear? So again we have to check here the test. So naturally again some dead load is there. So again we have to consider here tear that load. Okay, and again go to our XY parameters whether it is okay or not. Output parameter is okay. Now I start my test. Yes, start good. If you see here the graph which is showing the load versus displacement graph, and we have to see here the load which is increased by 4 km because we have to consider that delta value is 0.1%. Now if you see here that loading rate which is considered as a zero point 0.8, then again that wall it will be changed open, so naturally it is considered as 1.6. It's just like as a table of 8. ओपन करो ओपन करो थोड़ा और बढ़ नहीं रहा है Now see here, the displacement is zero point 0.4, so that graph is automatically changed. And the loading rate is gradually applied, not suddenly. So see here, the position of graph it will be changed according to the displacement value. ये पूरा दिखना चाहिए थोड़ा सा पीछे 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 Now see here, the loading rate that is automatically changed, but that is fixed, zero point 0.8 kilonewton per minute. Whether it is zero point 0.8, 1.6, 2.4, 3.2. Accordingly, it will be changed. Now see here, stress is directly proportional to strain. If load is increased, displacement is also increased. Only tension test, it required more time as compared to other practicals. But this is our loading criteria, that is we have to apply here gradually load. After that limit of proportionality, you have to the another point you have to consider here, that is yielding point. We don't know whether the yielding it will start or not. So after the completion of that, we have to check it. And we have to check here the strength criteria also, tensile strength criteria also. Stress which is equal to load upon area. So naturally here, the ultimate load, maximum load upon the area is pi by 4 into d square. And whatever the capacity of that material, with the yielding strength which is already given, whether it is 500 or 415 according to grade. So whether that per hour the bar which is used here, that is 500, and we have to check here whether it is greater than 500 or not. It totally depends upon the loading criteria. You can manually calculate it also, but here you have to get directly, because this machine is our computerized based machine. You can directly get all the output parameters which is already clicked in this particular experiment. Now see that graph, the nature, it will be changed now. Load is increased, displacement is increased. Now some fluctuation is also there. Similarly, we have to check where the neck formation it will be start in our specimen also. Once the specimen is break, it is break into two pieces having the shape of cone and cup shape. Isn't it? Why cone and cup? Because it is the failure which is occurs the shear failure. Shear failure which is occurs exactly at 45 degree of angle, either 45 degree or 135 degree. So always remember the material which is failure for shear, then tension, then compression. Always like that. So because of considering the shear criteria which is failure according to that 45 degrees, so naturally we have to get that specimen into two pieces having the two different shapes. One is cone and other is cup. We have to check it whether it is right or wrong after performing this practical. Now see here the nature of graph. Sometimes it is fluctuate less than that value. So means at that point you have to consider that is our yielding point. Where the straight line graph is there, so you have to consider that point which is considered as a limit of proportion. After performance the practicals, it is clear. You have to export that graph in PDF form also, or you have to consider as a image also. So by using after performance the practical, you have to take print out and then fill all these things as per our observation criteria or as per our conclusion. What is the modulus of elasticity, what is yield strength, what is upper yield, using that graph. Now see the load which goes decreasing side sometimes. Now see the value of load which is reduced now. The graph goes on downward side. Then again it is increased. Now this is our final graph which is showing all these values. Okay. Now see here the percentage of elongation with respect to gauge length. Today it is wrong now because we don't measure our gauge length. We have to measure it first, then put their value, then we have to check the percentage of elongation. But normally we have, according to our IS for that percentage, it should be 25%. Okay, 20 to 25% within permissible limit. If it is there, then we can say that our bar which is passed for construction. Clear? And we have to check here the yielding stress, yielding load, breaking stress. It is kilonewton per mm square. Okay. So here if you see the tensile strength is kilonewton per mm square, that is 740, which is quite greater than our as per our IS code requirement, because this is the 500 bar, 500 grade of steel bar. So naturally we have to require. So it is more than that, means our bar which is passed for construction. So this is our the final graph, but we have to check here the percentage of elongation. We have to put here first value of gauge length. We have to measure it, and then we have to finalize our graph. Clear? And we have to check it whether our graph which is break into two pieces, whether it is in cup or cone shape or not. निकालो. Now here we have to measure the final gauge length and then put our value. Now see, this is our bar which is cut it just like our cone shape. Okay, and this is just like our cup shape. Clear? So we have to measure the dimension. Measure for this. कितना है 50. We have to put here 50 value. Okay, and then we have to check our graph also. Now see here, the elongation is 25%. Clear? Okay, now print screen here, or we have to export here that data also. So I print screen and prepared one folder.